Hello class, Professor Anderson here. Let's take a look at another example of calculating the electric field from an equipotential. And let's say that we do the following. We have an XY coordinate system. And let's draw our equipotential lines in this direction right here. I'm going to use yellow for this. Okay, there's an equipotential. We'll say that that is at minus 100 volts. Equally spaced from it is another equipotential at 0 volts. And finally, a third at 100 volts. And let's say that this thing makes an angle of 45 degrees with the x-axis. Okay, so these equipotential surfaces are stacked like that. And let's ask the following question. Let's say that we want to calculate the electric field right there. Okay, what is the electric field at that point right there? And we need a little bit more information, right? We need to know these distances. So just to be simple, let's say that this is, how about 1 meter? And this is also 1 meter. All right, 100 volts every meter. How do we figure out the electric field right there? And how do we figure out the direction? We want the magnitude and we want the direction because it's a vector field. Okay, let's think about this. We know that the E field is negative del V, which is really kind of like negative delta V over delta S. Right? Electric field is in units of volts per meter. Okay, which is exactly what we get right here, volts per meter. Okay. How do we think about this? This is high voltage here, this is negative voltage over here. And so this is kind of like having a bunch of positive charge, and this is kind of like having a bunch of negative charge. And so the electric field clearly has to point in that direction. All right, one way to think about this is sort of like the mountain range. As the mountains get higher, as you go to higher potential, which way would you roll if you just put a ball on it? It would roll down the hill. Okay, so E is in that direction, but how do we calculate the magnitude? Well, all we really need is delta V over delta S, the distance that separates those equipotentials. So if I go from here to here, what do we get? We get 100 volts minus negative 100 volts. And delta S over that distance is 2 meters. All right, 100 plus 100, negative of that is negative 200 volts per 2 meters. And so that is negative 100 volts per meter. Now, if you just want the magnitude of E, then it's just 100 volts per meter. And now you have to pick a direction. Well, since these things are oriented at 45, and we know that the electric field has to be at a right angle to the equipotential surfaces, it has to be pointing right back down towards the origin, which would be 45 degrees below the negative x-axis. Okay, that's what it looks like. That's the value of it. Hopefully that's pretty clear. Cheers.